Hi, I'm Wencan Zhang, a PhD student from the Ubicom lab at the National University of Singapore. Today, let me introduce our paper towards relatable explainable AI with the perceptual process.
Hey Wencan, you are sounding fearful. Cheer up.
Well, you're right. You know, it's my first time to present at CAI. But how do you know that I'm fearful?
Because your speech looks like this, and the highlighted regions reflect fear.
As we can see, although the saliency map with the spectrogram can faithfully explain speech recognition model's decision, it doesn't make sense for end users. Since the information is too technical to understand and doesn't provide relatable semantics, more importantly, the model doesn't think in a human-like manner and explain itself accordingly. All these pitfalls will limit the model's interpretability to end users, which hinders the deployment of AI services on various real-world applications. To mitigate the previous problems, we argue that explainable AI should be relatable to abstract concepts, exemplars that are representative to the concept class, and cues that describe in terms of human understandable semantics. Inspired by the human perceptual process from cognitive psychology, where, given the stimuli, we select salient parts, organize them into cues and interpret them by recalling relevant concepts and associated cues, comparing their similarity to the stimuli and categorizing to a concept. We propose the XAI Perceptual Processing framework with corresponding capabilities. Next, let's see how the perceptual process can guide us towards more useful explanations. Let's consider the application of predicting emotion from people's voices. Suppose our AI hears this voice.
Dogs are sitting by the door.
And predicts it as fearful. We can compare it with some other counterfactual emotion.
Dogs are sitting by the door.
We can also analyze how the two voices are different with contrastive cues and see which parts were especially salient. So, how can AI support these explanations? Inspired from the XAI Perceptual Processing framework with different interpretability goals, we propose RexNet, the Relatable Explanation Network. Starting with a convolutional neural network to predict the emotion of a voice clip, we developed several modules for different explanations. First, it generates a saliency map of which parts of the input are important for the prediction using RegCam. Second, it focuses on the salient regions and calculates cues, such as pitch and volume of the voice. Third, it generates a synthetic example of an alternative prediction class, such as a counterfactual angry voice. It also generates the saliency for that example and contrast between the counterfactual and factual instances, and calculates cues for both instances. With both absolute cues, it can then calculate their difference to get the contrastive cues. Finally, RexNet takes all this intermediate explanatory information to make a final conceptual prediction of the emotion. Unlike most XAI methods that provide post-hoc explanations, RexNet is designed to be intrinsically interpretable and provides anti-hoc explanations based on corresponding modulus. There are three main explainable modulus in RexNet: contrastive saliency, Conterfactual Synthetic, and contrastive cues. Let's look into more details. Given the original voice to be recognized,
Dogs are sitting by the door.
we used StarGAN, a generative model, to construct realistic speech samples as a counterfactual synthetic explanation, which converts the speech into a specific emotional style, such as angry.
Dogs are sitting by the door.
During this process, other speech information such as the speaker's identity or the lexical content would not change. The counterfactual can provide users a reference state for their auditory perception, but it would be better to provide users more information. The saliency map is a common technique to explain which pixels are important for an image recognition model. Inspired by that, we use the saliency bars to highlight important word segments for recognizing emotion from voices. In addition, some segments would always be highlighted with regard to any emotion, which makes them less indicative. We introduce the discount factor and propose the contrastive saliency to de-emphasize the influence from those segments. Similarly, we can get the contrastive saliency for the counterfactual sample. Prior psychology studies indicate that vocal cue patterns vary with emotions, which can help people distinguish between emotions. Inspired by that, we firstly obtained the absolute cue patterns from voice clips, and then provided the contrastive cue as another explanation, which describes the relative cue relation. We eventually combined the perception level Conterfactual Synthetics and the semantic level Contrastive Cues to support user to recognize the neutral concept from speech. We conducted a modeling study to evaluate the model performance and explanation faithfulness. With 14 participants, we explored the usage and usability of relatable explanations in a formative user study. And with another 175 participants from MTurk, we quantified the usefulness in a summative user study. Specifically, to verify whether our method is good enough in terms of the prediction performance and explanations, we compare a CNN-based speech emotion recognition model against RexNet. The results from our modeling study indicate that RexNet can improve the emotion recognition accuracy, probably since the model is trained to be aware of cue information. We also confirmed that RexNet can provide faithful contrastive saliency, reasonable reconstructed counterfactual explanations, and accurate cue relations. Next, we use the Relatable XAI user interface to evaluate participants on a vocal emotion recognition task based on human simulatability, where they needed to listen to the voice clip, view any explanations depending on the pre-allocated conditions, rate how helpful the explanations were, and label the emotion in a balls and beans question. Here, the balls and beans question can accurately capture the user's confidence of the correct label, even if her most likely choice is wrong. In the formative user study, we explored how usable are relatable explanations. The results show that counterfactual samples are more intuitive, while contrastive cues and contrastive saliency are used to confirm users' initial judgments. They would make decisions by interpreting experientially based on the voice they heard and semantically based on cue descriptions. We also observed the misinterpretation on saliency bars. Maybe it's too technical for lay users. Identified that the machine-generated saliency bars may not well align with the human's mental model. To answer the question, how useful are relatable explanations, we asked participants' perceived explanation helpfulness and also objectively measured by recording whether they could correctly label the emotion with the help of AI and explanations. Compared to the baseline condition no explanation, we found that participants perceived all explanations as more helpful. However, including saliency explanations may degrade their decision performance, which can be explained by the misalignment issue in our previous qualitative findings. Therefore, we conclude that relatable explanations are useful, but they need to be collectively coherent. To summarize, we contribute an XAI Perceptual Processing framework with the RexNet model that can provide multiple relatable explanations, which is also the first time to provide human understandable explanations for audio prediction. Thanks for listening.